On page 106 from question number 1, we're going to do 1H, 1J, and 1N. So H, J, and N. On question number 2, we're going to do parts L and part N. So let's get started here. Here we have an isolated radical, 1H, square root of x squared over x minus 2 equals 3. So if I square this side and square that side, that'll make it simpler to deal with solving for x. So the radical is already isolated. We don't have to move anything from the left to the right or vice versa. And if I square the left-hand side, I get this. And when I square the right-hand side, I get that. So this under the square root squared cancels, the squared cancels the square root sign, and I get what's here, x squared over x minus 2 equals 3 squared, which is 9. Now I can either multiply both sides by x minus 2, or I can cross multiply. So if I multiply by x minus 2 here on the left in the numerator, that will cancel the x minus 2 on the denominator. So I get x squared equals, and then I have to multiply the 9 times the x minus 2. If I remove the bracket, I get 9x minus 18. And I transpose it from the right to the left, I get minus 9x and plus 18 equals 0. I can factor this and give as follows. You can see the first times the first gives me x squared. The inner is minus 6x. The outer is minus 3x, and they sum to minus 9x. And finally, the last, minus 6 times minus 3 gives me plus 18. So these are the two factors. If this equals 0, then x minus 6 equals 0, and x equals 6 is one solution, and x minus 3 can equal 0, in which case x equals 3. So we have two solutions, and we're going to check both of them. If x equals 6, I put 6 into the left side of the equation. I get 6 squared, 6 minus 2, 6 squared is 36, 6 minus 2 is 4, 36 divided by 4 gives me 9 under the square root sign. Square root of 9 is 3, and the right side of the equation is 3 right here. So now we check with x equals 3. We put it into the left side of the equation, x squared over x minus 2 square root of 3 squared, 3 minus 2, this is 9 over 1, which is 9. Square root of 9 equals 3, and the right side equals 3. So these are two solutions for that problem. Now, in problem 1J, we have 4 root x, 17x minus 4. We have radicals on both sides. The most easiest thing is to square both sides. So first of all, we've rewritten the problem. We square the left side, we get this. We square the right side, we get that. So 4 times 4 is 16, and the square root of x times the square root of x is x, so we get 16x on the left. And this cancels out the square root sign, and I'm left with 17x minus 4. Now I transpose, I can bring this from the left side, from the right side to the left, in which case I'm going to get minus x on the left equals minus 4, or x equals 4. So now we go back and check. The left side of the equation is 4 root x, which is 4 times the root of 4. The root of 4 is 2. 4 times 2 is 8. We take the right side. We get the root of 17x minus 4. 17x is 17 times 4, which is 68, minus 4 is 68 minus 4 is the square root of 64, which equals 8. The left side equals the right side, so the solution x equals 4 is valid. Now here we have a number here, and here we have a number here, so we can do a number of different things. What I've done here is to solve for the square root of this. So I want to isolate the radical by itself. I want to isolate this by itself. So in order to do that, I have to transpose this to that side, 75 minus 35.5, and divide by the coefficient here, 2.5. So isolating what's under the root sign, x minus 6.6 here, or isolating the total root sign, I transpose this to this side and then divide by this coefficient, and I get 15.8. 75 minus 35.5 over 2.5 is 15.8. So I've isolated the radical with this, and I've just got a number on this side. This calculation, of course, you can do with your calculator. Now, what I do is, once I've isolated the radical, I square this, and I also square that. What I do to one side, I have to do to the other. So this becomes x minus 6.6. 15.8 squared becomes 249.64, and I transpose from the left to the right and add the 6.6 to the 249.64, and I get 255.24. I go back and put that number into the right side of the equation. Here's the right side of the equation. I replace the x with a 255.24, and I subtract the 6.6. So I get 2.5, 248.64, which is this here, plus 35.5. The square root of 248.64 is 15.77. I multiply that by 2.5, and I add the 35.5. I get 74.9 as the right side, and the left side is 75, so this is close enough. So here you can see I have 2x equals this, and the easiest thing to do is just rewrite this first of all and then square both sides, because squaring both sides I'm going to get rid of that root sign here. So 2x squared is 4x squared. This square here and the root sign in a sense cancel each other, and I'm left with what's under the root sign, 5x squared minus 3x minus 10. I transpose the 4x squared from the left side to the right side. 5x squared minus 4x squared gives me x squared. This term is this term, and that term is that. I factor this as x minus 5x plus 2. The inner term is minus 5x. The outer term is plus 2x minus 5x, and plus 2x sum to minus 3x. And minus 5 times plus 2 gives me minus 10. So there are two solutions, x equals 5 and x equals minus 2. If I check the value x equals 5, the left side of the equation is 2 times 5 right here, which is 10. If I substitute the 5 into this, x squared is 25. 5 times 25 is 125, minus 3x, minus 3 times 5 is minus 15, minus 10. So 125 minus 15 minus 10 comes out to 100, and this is under the square root sign, so we get 10. So the left side equals the right side when we use x equals 5. Let's check the other answer. X equals minus 2. 2 times x is minus 4. And we substitute the minus 2 into the 5x squared. X squared is 4. 5 times 4 is 20. Minus 3 times minus 2 is plus 6. And minus 10. So I get 26 minus 10, which is 16. Square root of 16 is 4. It doesn't equal the left side. The left side is minus 4 right here. So minus 4 doesn't equal 4. And so the x minus 2 is extraneous. The only solution is 5. Now, in this case, you can see what we're going to have to do. We're going to have to isolate the root, the radical sign here on one side, and move this over to the other side. That way, when we square this, we're going to come out with 3x plus 7. So, square root of 3x plus 7 minus 2x minus 1. The first thing is we transpose this from the left to the right, and we get this right over here. And then we square it. So we're doing two things at once. We're taking this, going down here, squaring it, moving this from the left to the right, and squaring that. So this is 2 times 2 is 4, and we're going to square the x minus 1. This is the 3x plus 7 obtained by squaring this, which is under the root sign. So we have 3x plus 7 equals, now, when we expand this, it's going to be x squared minus 2x plus 1, so multiplying the 4 times the x squared gives us 4x squared. The middle term here is going to be minus 2x. When we multiply that by 4, we get minus 8x. The last term is going to be plus 1, and when we multiply that by 4, we're going to get plus 4. Now we collect like terms. So there's only the 4x squared. We're going to leave the 4x squared right here. We're going to bring the 3x over to this side, and it'll be minus 3x. Minus 3x and minus 8x will give us minus 11x. We're going to transpose this from plus 7 over to this side, becomes minus 7, and 4 minus 7 becomes minus 3. So this is the final quadratic that I'm going to obtain. I'm going to factor that, and I factor it as 4x plus 1, x minus 3. And so 4x times x gives me 4x squared. The inner term is plus x. The outer is minus 12x. Minus 12x plus x gives me minus 11x. And plus 1 times minus 3, the last term, gives me minus 3. So I'm going from this and just showing that this is correct. There are two solutions here. If 4x plus 1 equals 0, one of the solutions is x minus a quarter. Here, the other solution is x equals 3. So now, we're going to substitute with x equals 3. 3 times 3 is 9, plus 7 is 16. 3 minus 1 is 2. Minus 2 times 2 is 4. So we have the square root of 16 minus 4, and that's 4 minus 4, which equals 0. So that works out. Now when we check with x equals minus a quarter, we replace the x here with minus a quarter. We get minus 3/4 plus 7. Here we're replacing the x with minus a quarter. So we're going to get a common denominator here. This is 28 over 4. Instead of writing 7 over 1, we're going to write 28 over 4. 28 minus 3 over 4 gives me 25 over 4. Here we've got minus a quarter, minus 1, so we've got minus 1 1/4. Multiply that by minus 2, I get plus 2 1/2. 2 1/2 is the same as 5 over 2. And so The reason I do that is when I take the square root of this, I get 5 over 2. The square root of the top is 25. The square root of the bottom is 2. And I got 5 halves here. 2.5 plus 2.5. If you want, you can add these two. 5 and 5 is 10. Over 2 is 5. And so this does not equal the right side. If you look at the right side is 0 right here. So the right side is 0. So this solution doesn't work, and the only solution is x equals 3, and the x equals 5 is an extraneous solution. Okay, this is the next page, so I'm not going to do that in this video. So this completes our discussion of, let's go back a page here, sorry about that. Okay, so this is the last problem on page 106, and that completes our discussion.